Hi, in this video we're going to learn how to perform composition of function. This is how the formula looks like, and we will learn how to perform the operation of composition of function. Let's begin with your basic concepts. A composite function is a combination of two functions. You apply one function to the result of another. The composition of the function f with the function g is written as in this symbol, which is read as f of g of x. f of g of x. It is also known as in this symbol, which is read as f composed with g of x. f composed with g of x. In other words, they are just the same. F composed with g of x is equal to f of g of x. But actually, this is the easier one to use. You will understand why. Let's have an example. Given is f of x is equal to 2x plus 5 and g of x is equal to x minus 3. You are going to be asked, find g of f of x in terms of x. You can actually write your g composed with f of x, but actually you need this formula g of f of x. This means your x value in your g function will be the f of x, which is 2x plus 5, which means this whole value will be substituted in the x of the g. So supposed to be we have x here as your g function x minus 3, but since we are performing your composite function, which is f of x, will be plugged in your x of g, so this becomes now 2x plus 5, which is your f of x value. It's almost done. You just take down your parentheses and perform subtraction between 5 and 3. 5 minus 3 is 2, and that is composition of function. Now, how about the reverse? What if you are asked f composed with g of x? Will they have the same result? Let's see. So you have f composed with g of x is actually the same as f of g of x, which means in our f function, let's replace this first. G of x is x minus 3, which means the whole x minus 3 is plugged in as a value in your f function, in your x on the f and the f function. So supposed to be you have 2x plus 5 as your f function, but since we are going to perform your composition, this is originally x in your f function. It's now gonna become x minus 3. And here we go, we do 2 times x, 2 times negative 3 by distributive property, which will become 2x minus 6. And then copy 5. And then combine negative 6 and 5. Negative 1. And that's your final answer, 2x minus 1. Do you remember your g composed with f of x? The answer is 2x plus 2. Therefore, switching f and g, or two functions, switching places, they will have a different result. They are not the same result. So, meaning to say, switching the two function places will not have the same result. It is possible that they have the same result, but as shown here, probably most of the time they will not have the same result. Let's have some more examples. Now let's try this next set. You have function f of x is equal to 2x plus 2, g of x is equal to x squared plus 2. Let's try your g composed with f of x, which means you have g of f of x. First step, you just replace this with your function f of x, which is 2x plus 2, which means this whole 2x plus 2 is your new value of x in your g. Supposed to be g is square of x plus 2, but since we're performing composition, the whole x now from the g function will become 2x plus 2, which is your f. Now you're going to perform your binomial square or FOIL. Here is a shortcut. Supposed to be you square your first term 4 squared, 4x squared. Your last term is 4. Now the middle term is supposed to be a combination, or you add your outside pair and your inside pair in your FOIL. But here is the shortcut. 2 times 2, 4. 4 times 2x is 8x. Again, the power 2 times 2, 4. 4 times 2x is 8x. Remember, your first term is supposed to be the square of the first term, 4x squared. The square of the last term, 4. The middle term is 2 times 2, 4 times 2x, 8x. Bring down, copy your 2. 4 plus 2 is 6, and it's done. Your result of g composed with f of x is 4x squared plus 8x plus 6. Let's try the reverse. Switch f composed with g of x, which means we are going to perform f of g of x. By this formula, we will replace this with your g function x squared plus 2. Now, it's a reverse this time. Your x squared plus 2 is going to be your value in the x of the f function. So, supposed to be f is 2 times x plus 2. But then, we are performing your composition, so we are going to replace the x here with the x plus 2, which is your g function. This will be a little easier because unlike your g of f of x, you are going to square a binomial. Here you just perform distributive property. You have 2x squared plus 4, and then copy 2, and then add 4 plus 2, 6, and it's done. Okay, so obviously again they don't have the same answer. So g composed with g of x, your g composed with f of x most of the time will not have the same answer with the switch of which is f composed with g of x. Okay, let's have one more set of example. You have your f of x is 3x minus 1, your g of x is 2x squared plus 2. Let's try first your g composed with f of x, which means you have g of f of x, which means f of x is 3x minus 1. Hold on, 3x minus 1 will be your x value in the g function 2x squared plus 5. We are going to replace the whole x, the x with 3x minus 1, but there's a power from the value here. Again, the shortcut will be first term 9x squared, the last term 1. The middle term will be 2 times negative 1 is negative 2. Negative 2 times 3x is negative 6x. The first term is 9x squared. The last term is 1. 2 times negative 1 is negative 2. Negative 2 times 3 is negative 6x. That's how you do shortcut on your square of binomial. Then you perform distributive property. You cannot add 1 yet. By PEMDAS rule, multiplication first before adding. So you have 18, negative 12, 2. Copy your variable, copy 5, 2 plus 5 is 7. And that's your g composed with f of x, or g of f of x. Let's try the switch. You have f composed with g of x, or f of g of x. To show work, you have to replace g of x with the value 2x squared plus 5. So you have f of 2x squared plus 5, which means the reverse, the 2x squared plus 5 is going to be your value of x in the f function. Your f function is supposed to be 3 times x minus 1. So this is supposed to be x, but since we are performing composite function, so this becomes 2x squared plus 5. And then perform your distributive property. You have 3 times 2, 6, 3 times 5, 15. 15 minus 1 is 14. And it's done. You will ask, why do we need to learn this? This is so complicated. What is this for? We will need it later on for your lesson of inverse function. Other than the function operations we learned, which is addition, subtraction, multiplication, division, this is really unique, and it will be applied also on a unique topic, which is also only about function, which is inverse of function. Okay, you can watch the video again if you need to review. Thank you.